Oh no, I did not record any of that. So, looking at this, I will say the mild section does say at the end to determine what form right here. Standard form. It does say to do that, okay? But that's not what I'm asking yet. So, I am going to eventually ask you to do that, so let's go ahead and do it since so many of us jumped there. But be careful about following instructions. I saw a lot of us drawing this area model, and I want to emphasize and I want to remind you, when you use this area model, what is this area model helping you do?
Convert factors.
So it can help you convert from factored to standard, or it can go from standard into factored, right? Now, with that in mind though, I want to ask this question, because I want it to be very clear. I was talking about this with Miss Beasley, who teaches pre-cal. And some students are missing this detail, but I need you to understand why, and this is what she was asking me to make sure students understood a little bit better. Why is this helping us go to standard form? What is that area model helping us do? That's just a model to help us do something.
Help us distribute.
Do not forget, I need you to understand this. I need eyes and ears here. Damon, and it helps to have eyes and ears here, Allie. Okay, when we are multiplying this right here, we are taking this x and multiplying it by x squared, right? What does that give me? X cubed. I then take this x and I multiply it by negative 2x. What do I get? Negative 2x squared, and x times negative 8 is? All this has done is help me take my x and distribute it to this. That's what the area model is doing. It's just a model to help me distribute, or to go from that standard back into the factored, right? But don't forget what it's actually doing. Area model is just a model to help me distribute. It helps us stay organized and know where everything is going. So that's what it's doing though. It's helping us distribute. You don't have to use the area model. A traditional way that I was taught was just to take this x and distribute it to each of these terms. You can draw the little arrows, which is fine, but what I found personally is that I can get lost and I miss some of the like terms. This doesn't do that. This is what Miss Granberry uses, this is what Miss Williams used. Just keep in mind that this is helping us distribute. That's what it's doing. Negative 3 times x squared gives me what? Negative 3x squared. Negative 3 times negative 2x is 6x. Notice when it's a positive 6x, I still put the plus here because I'm adding it. And it was negative 3 times negative 8. So I have distributed. Now I have to add my like terms. And the beauty of the area model, the reason why I push and recommend the area model so heavily is because of this right here. What's along this diagonal? Those are like terms, aren't they? What's along this diagonal? Like terms. It doesn't always happen that way, but when there are like terms, they will be along those diagonals, okay? So keep that in mind, pay attention to that. So after I multiply it, f of x equals what? Keep in mind that area model is helping me distribute to get to that standard form, okay? That's what's happening there. So I want to make sure that's clear. But for those of us who did that, that's not what this question was asking, right? What did I ask you to do? Find the zeros. What do we got to do to start finding zeros?
Set the factors to 0.
Okay, even before that step. I'm not gonna, I can't start with setting the factors equal to 0. I gotta start with setting the equation or the whole function. Notice there was an f of x here. I gotta set that f of x equal to 0. The setting of the factors equal to 0 is actually step 2. Because what can I use once that thing is equal to 0? Say it louder.
0.
Zero product property. The whole idea is I got multiplication. I got a product that is 0. So when I multiply these together, if their product is 0, one of those factors has to equal 0. So either what is true? Either x minus 3 is equal to, or and what I'm asking you to do is to find those zeros, okay? Now as a quick recap, because the whole reason I'm asking you to do this is it's going to help in your test that I'm giving back to you tomorrow. It's going to help in the next unit. It's going to help give you a chance to master these concepts from previous units, because I'll be passing out your proficiency scales up to this point tomorrow, physical copies, and we got to look to see what we need to build understanding of over the next 3 weeks. Now, I will say, I can find this 0. What am I going to do from here? Add 3 to both sides. Easy money, right? X is equal to 3. And notice, like, the whole idea is I'm eventually going to try to graph my original function. So I'm going to go ahead and mark my x-intercept, my 0 there. But I need you to now find these zeros. What kind of equation is that? It's a quadratic equation. It's in standard form, but it is a quadratic equation. And it's in standard form. So I can't solve it right away. What are some methods I can use to solve that equation? What were some of us looking at doing? Say again. So could I use that? Well, now what would the area model help me do? The area model would help me go from standard to factored. So the area model could help me factor it. That's one method. What else could I try to use here? I could convert it to vertex form and then use my inverses with properties of equality. What are the other 2 options? That distance method, right? H plus or minus the distance. What's the last method? My least favorite, the quadratic formula. I don't care which method you use, but work as a group, so make sure that everyone is working on it together in that same method so you can help each other, okay? If you've already done it once, because you're like, I saw it already, decide together what method you're going to use and do a new method, okay? So let's get to it. Just 2 minutes or so to solve this quadratic, and then we'll bring it back together. You want to get to a vertical surface, you can do that as well. The board somewhere. And so that's really, really exciting for me. So right here, I first want to point out and remind you, so this group here and that group over there, y'all chose to factor, right? So we took our standard form and put that standard form inside of our area model, and then we factored. Now, what I do want to remind you of is, do you know what the only form that does not, or the only method that does not always work is? Factor. I don't know if you remember this, but I mentioned this before, that factoring only works when you have rational roots. Factoring only works when you have rational roots. So if you have imaginary roots or you have irrational roots, factoring just won't work. But in this case, did it work?
Yes.
Yes, okay. So it's nice and easy if you're comfortable with it. One thing for the groups who didn't do this, remember x squared minus 8, that's from the original equation, right? X squared minus 8. To find these, we had to take our a times c, so a was 1 times c, and we had to find factors of that added up to -2, right? So negative 4x plus 2x, and then we could factor easily, right? So factors are x minus 4 and x plus 2. And so from our factors, nice and easy to find our zeros, use that zero product property, etc. So what roots do we get? Positive 4 and negative 2. Okay? Now I want to point this out back here. So Damon, I assume / hope you worked with your group on this. You didn't just do it all on your own. Is that right? Did you do it all on your own? Damon, we're supposed to collaborate in our groups. That's my bad for assuming. So right here, what did this group use? What method? Who? Does anyone know that they're planning to check out?
Me.
Actually?
Yes. That was me.
You sure it wasn't?
No.
Is it actually you?
Yeah. I was gonna come with
Okay. So looking at this, what method did Damon use?
Quadratic.
Quadratic formula, right? Negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Now I want to highlight a couple of things that I really like about what Damon did. So the opposite of b, right? So when we do the opposite of b, he literally put the -2 inside of parentheses so it makes it clear. Because when you have two negatives, they become a what? Positive, right? It's the opposite of -2. So we get a +2 here. Inside of here, very intentionally put that b squared, the b inside of parentheses. If you don't do that, the calculator will often give you the wrong answer because it'll do -2 squared giving you -4 when it should be +4. And I really like, and this is what I really want to emphasize right here, the first real step he took was he simplified the what? What do we call this thing right here?
The radical.
Close. Radicand. So remember, the radical is the square root symbol. The radicand is what's underneath the radical, right? And so he simplified that radicand because right away, when I see that right here, I know I'm going to have what kind of roots? Not just real, but yes. I also know I'm going to have, say it louder, rational. If this had been a 40 here, that'd be irrational. How do we know that's going to be irrational? Not just because it's square root. Because what? It's not a perfect square. So remember how we had a 36? I could take the square root of 36. I can't, well, I can take the square root of 36 and get an integer. I cannot take the square root of 40 and get an integer. So I really like that simplifying the radical. I do also, Jeremiah, love it because it shows us right away if we're going to have imaginary roots or imaginary zeros. And so, can you silence that, please? Now, we did skip a couple steps that I do recommend. What is the square root of 36 again? 6. So I would have written that out separately. But what is 2 plus 6? 8. And what's 8 divided by 2?
4.
And what's 2 minus 6?
-4.
And what's -4 divided by 2? -2. Right? Okay? So, different method, but is that the same story? Yes? Okay, so last, not completely last. Sure, go quickly. So I want to look at this method right here. I didn't even have you in the shot, Damon. You was freaking out for no reason. All right. So what method was used right here? This was the vertex form, right? Now, one thing I will say, I would highly recommend not put that dash there, because what does that look like? Minus, negative, double negative, something, right? So I would probably put what's a colon here. I don't know if you know this, but what comes after a colon defines that thing. So we are defining A as 1, defining B as -2, etc., right? So we found H, the opposite of B, divided by 2A. So we get a 1. And how do we find what K is?
I'm putting our H into our...
So remember, when we substitute H in, we get out K. This is why I love function notation. It very clearly shows the input that maps to the output. And so my K is -9. Okay? And so I'm going to rewrite it over here so it's more clear. What do we do once we get it into vertex form? What do we do?
Get the square root.
Set it to 0.
Five.
It's already equal to 0.
Get the
Plus 9 both
You gotta do
sides.
the onion, you
I
gotta
gotta peel that onion, right? So but like when we say peel that onion, we mean use what? So in the same way, like peel the onion was just to help us remember this. What are we trying to use? We're using, so it is something with properties of equality, inverses. Remember, peeling away, you're pulling away those outer sides of the onion. It's using those inverses to get down to that variable x, right? And so don't forget the order that you have to do it in. This is one of those things I really emphasize. Remember your order of operations. Because if I started with this x, what's the first thing happening to x? Subtracting by 1. What's happening to x minus 1? It's being squared. What's happening to x minus 1 squared? Subtracted by 9. And that's the last thing happening? That's the outermost layer of the onion? That's the thing I'm undoing, huh? That's the first thing I undo. Plus 9, plus 9. 9 equals x minus 1 squared. Now here is the main place that people make a mistake if they use the vertex form. What is it? Right, when we take that square root, one thing I'll point out is pay attention to your order. The idea is I'm trying to get to x, so I added 9 first. Here, I need to take the square root of the right-hand side first And because I did that, I take the square root of 9. And then you're 100% right. The most common mistake is students forget to put the plus or minus, or the positive or negative right there, the adding and subtracting of 3. All right, but now I've finished peeling the layers of my onion. I love this method personally. What's 3 plus 1?
Oh,
And 3 minus, or negative 3 plus 1?
negative.
Negative 2. Same exact solutions, right? Notice it doesn't matter what method you use. Sometimes you can't use the vertex or the factoring, but you can always use the other methods. All right, so here's the kind of wrap up that I want to do with this. So, excuse me. Just trying to make sure we can all see it up here. And I'll talk about y'all's distance method later. I just want to focus on this. All right. The goal of this whole unit, last unit and this unit, is to help us understand what a polynomial function looks like without necessarily using a graph, okay? And so I want us to pay attention to this. We found our root from x minus 3 earlier. It's right there, x equals 3. We just found our roots from this quadratic, right?
Yeah.
They were 4 and negative 2. And so we have this cubic function. Should have how many zeros? And how many do we have? They're all real, so it's easy to see them. But I want us to now try to figure out what does this function look like without drawing the factors. Last unit, the whole idea was if I have the factors, then I can easily figure out what the new function looks like by looking at the positives and the negatives, right? So this time though, what's something we know about this function to help us start graphing? What's positive?
The leading coefficient.
So the leading coefficient, but remember now, because when we talk about quadratics, we just have concave up and concave down, but when we talk about cubics and quartics, there's multiple concavities, right? So the leading coefficient is positive, so what does that tell us about the function?
It's going to be positive.
What's going to be positive? The
Our
whole
end
function?
behavior.
Our end behavior? So it's going to be like this. That's what our end behavior is going to look like?
No, because our degree is different for odd.
Our degree is odd, so the end behavior needs to be different. So, okay, so this is where we need to be careful. We can't just say positive or negative. Does it look like this different end behavior, or does it look like this different end
The
behavior?
first one, because it's increasing.
If it's positive, we need to recognize it's overall increasing, right? So it should look like this. All right, there's my end behaviors. Now I can fill in the rest. Right here at this 0, do you think it's going to go through into the positives, or is it going to do something different? Why is it going to go through?
Because you don't have a double root.
It's not a double root. If it was a double root, Jeremiah, what's going to happen there? It's going to bounce. But we don't have a double root. We have a single root. And what happens to those singles? It goes through, right? Okay, so it goes through, and it's going to come back to the next 0. What's going to happen here? It should go through, right? And then come back up, and then go. So notice by understanding my multiplicity of roots and understanding my end behavior, I can now sketch out this function. Now, let's check this against what the factors tell us. So the original factor, first factor is x minus 3, had an x-intercept of 3, a y-intercept of negative 3. So that is what it looks like. There's y equals x minus 3. And x squared minus 2x minus 8 had these zeros, and it was concave up. I need us to pay attention to this. What's a positive times a negative? And what does the cubic have right here? Negative values, right? In between these two roots, my parabola has negative values, the line has negative values, and what's a negative times a negative? And what do we have right here? Positive. The line has what type of values? Positive. The parabola has what type of values? And a positive times a negative is? And look at what is happening with that cubic. And then what's a positive times a positive? So notice, if we understand end behavior and we understand our roots, that's going to bring together everything we have learned about polynomials. I don't have to have the separate graphs of the factors anymore if I have the roots and I have the end behavior and I understand how those roots operate. So we are not telling a new story, we're telling the same story from a different perspective. And when you learn the same story from different perspectives, it deepens your understanding. Okay? So, I'm going to let you take a few moments to write down anything you need to, just a minute or so, to write down any notes you need to on that section, and then we're going to get into the majority of today's lesson. Actually, we're going to get... We didn't get a chance... I'll come back to it. When you get done with those notes, I want you to tear those pages out of a book. So find a book that has those pages in them.
Just leave it.
Huh? Hello? Yes, ma'am. Yeah. Okay. Sounds good. Yes, ma'am. Bye. Alright, so once you finish write down any notes you need to, find a copy of the book that has those pages in it. There are ones underneath the desk. First block has already torn some out, so you may have to find a book. Here's a couple books right here. But if there's 2 books under your desk, at least one of them has the pages. Has to be volume 1, yeah. As I said, some of them already have the pages torn out, so you'll have to find a book. Hold on. Can I make your life easier? Okay. So, instead of just ripping, take a second to make sure that the top tears like that, and then it comes out really nicely. It's more liable to rip if you don't take that extra second.
Like 5 books.
Yeah. Have you checked this book right here next to Jada? I don't know for sure, but. Or how about these under the Queens area? I don't think anyone's looked at those because we don't. Was it the papers in there?
Mm-hmm.
I would say I don't think anyone from First Block touched those. So look at those. All right, we're gonna get started while Tracy finds these pages. So here's what we're looking at. The very first kind of lesson page here. We are looking at a study, and we're not going to be able to do the full context. We just don't have the time today. But we have data here that shows how long the study has taken place, and then the average number of glass frog eggs that are found during that month, okay? And so that data has been graphed here. And what has been done is a regression analysis. That's a statistical idea. You don't have to worry about that part. But that has given us a function, right? So the individual data points from here, that's what the dots are. The curve here that is approximating those points, that is our function. First off, what type of function is this? I'll give you a hint, it's a polynomial. What type of polynomial though?
You said 225.
Quartet?
Yes, teacher. Why do you think quartet?
Because it has the double root right there, right?
Okay.
And then it intercepts the beginning, and then intercepts the last 4 times.
Okay, and I'll even say this, it looks really close, but there's actually 2 different roots. It's not even a double root. So there's how many roots? There's 4 roots. That would indicate that it's what? Quartic, or 4th degree, right? Sorry, hold on. Did you see Miss Upton before you head to lunch? Okay. Like, you can go now. Hey, Sky. It's not where you go. Miss Upton. Miss Upton. The nurse. Alright. Does anyone see another detail that probably tells us this is quartic? If if you go to, it's 226 and 227. If you look at 227, you might see something else. Huh? Oh, the number of turns, the extrema, right? How many turns we got? 3, right? So the degree minus 1 equaling 3, that degree is probably 4. There we go, yeah, And also look at the equation. I know you probably can't see it up there, but you can see it on the sheet of paper on page 227. If you tore 227 out. Or not. Anybody that has 227? Yeah, you didn't do the 227. Look for 227 as well in your book. Somebody, anybody? What's the degree? What's that power? It is 4. Matching 4th degree, your quartic. Woo! Alright, so we don't have a ton of time, but before you head to lunch, what I want you to do is I want you and your group to come up with just a prediction for what you think the domain and the range of this function are. We'll come back and talk about it after lunch, but I need you to come up with a prediction for what you think the domain and the range of that function are. So write it down on your desk. Just, what is domain, Caleb? Okay, it's just, see, that wasn't that scary. Was it? All right. That's what you need to keep in mind. It's all the x values, right? So Damon, what do you think all the x values might be?
Negative infinity to positive.
Okay, so negative infinity to positive infinity. Can anyone either push back on that or add on to explaining why they agree? Can anyone either push back or add on to explaining why they agree? Mimi.
I agree. Because if you look to the left and right, the endpoints, they both have an arrow, which means they're going for
So yeah, these arrows mean it's going to keep going, right? Is it ever going to quit going left? It's going up. Is it ever going to quit going right? What I would also point out, so nicely done. What I would also point out, and I want you to think about, is this. When I look at this equation and I talk about x values, what are x values also called? They are the,
Root.
The roots are only the x-intercepts. What'd you say? No? That's what you're saying? There's an I word. They're the inputs. Remember, x values, not just x-intercepts. X values are also inputs. Is there any number I could not put into that equation? I can put anything in. To show a contrast for when we might not be able to put something in, if I were to give you this equation, and I were to graph this on the real coordinate system, does anyone know any x values I could not put in? Say a letter. I could not put in negatives, right? So the domain here would not be negative infinity to infinity. If I were to give you this equation, does anyone know a value that x could not be? Say it louder. I can do a positive. Could I put a 2 in and get 1/2? Yeah, I can put a positive in. Say again. If I put a negative 2 in, I would get 1 divided by negative 2.
It can't be all
Can't be what?
whole number.
Those are whole numbers.
Like it can't be 1. Like it can't be 1 because it'll make a whole number.
So we can never do it imaginary because it would already be imaginary.
Can't be 1 because it'll be a whole number.
Well, 1 would give me 1 divided by 1, and what's 1 divided by 1?
1.
That works. It's still a point, right? Say it again.
0.
0! If I put 0 in, what's 1 divided by 0? Try typing 1 divided by 0 in the calculator. Somebody.
Undefined.
It is undefined. We need to remember that that's undefined. So what would not be able to be substituted in? 0, right? So there are some functions where you cannot substitute every x value in. With a polynomial, you can substitute anything in. All right, so there's my domain. One thing I would highly recommend is pointing out, labeling and annotating your graph could be evidence of understanding. So showing, hey, the minimum x, it keeps going left for forever, and so I labeled this is my minimum x and my maximum x. Remember, it's always a minimum first and then a maximum for that interval notation, okay? Alright, so earlier I saw Lily wrote down negative 2,500 to infinity for her range. Can anyone push back on that or add on to why they agree? So Lily said she thinks the range is negative 2,500 to infinity. Can anyone add on to or push back on that? Nobody? Okay, Tracy, when we say range, what do we mean?
All the way back.
All the y values, right? So in the same mind as our domain, if this is all my y values, which y value is this? Say it louder. Is that my minimum y value here? Yes, Mr. Kenny? Yes, ish. Are there any y values below this point right here? Nothing. So whatever that is, that's my minimum y value. Is that fair? You go with that, Tracy? Nothing below that. Okay, so then what's this infinity? Maximum what? Remember, we're talking about range. So why? Notice I'm annotating these numbers to make them make sense. And now I'm looking at this graph. Does it make sense that the maximum y value is positive infinity?
Yes.
Yeah, 100%. Now, I got to ask, Tori, do you think that this point is exactly negative 2,500? Daniel said no. Tori, you're saying no. Is that probably pretty close? Probably, right? Madison, do you have any idea how I could get a more precise value for what that y value is?
Can you do the maximum minimum on calculator?
Oh, could we use a calculator to find maximum and minimum here? I bet we could, couldn't we? Alright, so I'm going to have y'all work on the calculators a little bit later to do this, but right now I'm just going to pull it up on my computer, because I did it earlier. Okay, so I'm going to delete that. So I just want to point out really quickly. So all I did was I typed in the equation as it is on that sheet. And notice, I want to show this. What I got when I finished typing it in was this. Obviously, is that correct?
No.
No, that doesn't look right, does it? So what do I need to do to be able to see the graph the right way? Okay? I want you to see something. If I just zoom out, what's the issue with zooming out like this? Is it just moving out in the y direction? Look, it's also moving in the x direction. Do I need to move out in the x direction? Can't even see anything, can I? Let's go back to menu. Let's go to Windows/Zoom. Instead of zooming out, what could I go to? I always go to Windows settings. But what settings should I put in? You could always guess and check. But why don't you look at the graph that they gave you? What's the x-min on that graph? Look at the graph. What's the minimum x value that you see? I would say on that window that they gave us, when you look at this window, you look right here, what's that minimum x? 0, right? So I would put a minimum x of 0. What's the maximum x they give you on that graph? 50. What's the scale they go by? Notice it says x scale. What do they go by? 5. What's the minimum y value? Negative 5,000. Then a y max.
20,000.
And what scale do they go by? 5,000, right? Ah, that looks pretty darn close to what I see on their paper, doesn't it? Alright, now I want to find the minimum value, right? So, Madison, how do I find that minimum value?
You put it on the lowest.
What does that mean?
Close to the lowest term. Is that what you call it?
Alright, I put it there.
Like over a little bit.
Huh? Oh, that's right. I gotta go to menu first. Madison, stop skipping steps. Now where?
Analyze graph.
Analyze graph. Minimum. And Madison, I think you're right for once we get here. Just don't skip all the steps. Like, we have to select minimum first. And remember, lower bound, it just needs to be to the left. I hit enter. Now I need upper bound, and I hit enter. So negative 2,500 is pretty close, but what is it actually?
Negative
2,807.12. So make sure that we're using our calculators for this. I did that specifically because we're going to be using them in a second. I think it was 807.12, is that right? Did anyone write it down? Remember it? Yeah, alright. So, domain and range. Don't forget that we're just talking about our x values and our y values. Now, we have about half an hour left in class. I want to cover one more thing in class within that half an hour. And then I want to give you all some time to work on check your understanding for the stuff that's going to be on our test tomorrow that I'm giving back to you, the Unit 4 stuff. You can work on whatever you want, but you need to be actively working for the rest of today. We're going to skip all of this on 227. I want you to go, or 228 I think. I want you, trying to think. I don't want to make you all type that entire equation in for the sake of today. Do this for me. Number 2, I want y'all to do number 2 at your desk. We'll talk about it, and we'll leave numbers 1 and 3 for tomorrow. Those are some big ideas. I want to make sure that we get those down. So just do number 2. We'll get to 1 and 3 tomorrow. So work with your group. It's on the next page, not on page 229. Maybe looking at 229, like it says on the board. It's 228. I lied. 228. Number 2. I'm a dirty liar. I'm sorry. 229 is the really important part for tomorrow. Huh?
This is,
228. Or, yeah, 228.
yeah. So we did.
I'll put the graph back up if you need it for 228. Or for number 2. Printed is on the previous page as well. Hey, stop trying out my expo writing on your paper. I literally gave you lead earlier. That's all. Yeah, you definitely have it in your notes. But remember, we also took some notes.
Use
There
graph
in
and technology.
behavior.
Determine the
And we forgot to write the proper notation for it. It's on, nope, it was on that sheet. And behavior notation is somewhere on there. Look for where the proper notation for in behavior. It's on there. We did the bell ringer yesterday too. Word of caution.
Oh, we on number 2?
Right here. Remember, it's always a minimum and then a maximum.
This behavior.
Is that number smaller than that number? So then how's that line?
Okay, so it just makes sense in the context of this problem scenario.
Remember how we just wrote it a second ago? In behavior.
So, let's see.
Hurt my heart. Okay, if you want to join the non
In behavior is going the same way.
You're ancient?
Got our in behavior in there?
Whoa. Matthew, you can hit me.
I would agree with you, but that's not what I'm asking there. I wouldn't erase it. I'm literally asking you, what is the in behavior?
Oh, I can do that.
Yeah. Okay guys, really quickly, I need eyes and ears back over here because looking around the room, everyone is misunderstanding what I'm asking here. You are making the same mistake I warned you that students make every single year on assessments. Yes, that in behavior is the same. That's not what I'm asking.
Makes sense.
Right, remember, it's going up and to the left, right? So what is x approaching here? If it's going to the left, x approaches negative infinity. It's also going up, so what is up direction? What variable is that? It's what? Y. What is y approaching? Infinity. So on the left-hand side, as x goes to negative infinity, what does y go towards? Infinity. Guys, if I ask you about in behavior, I need you to tell me that. Not that they're the same or they're different. You have to figure that out. And then you have to identify what the actual in behavior is. Identify what the right-hand side in behavior is. I've only done
What are the
left-hand.
pages we got written out?
Here.
I want to do.
Because we tore these out before lunch.
No caller. Alright, he said you gotta.
You got your in behavior over there? I don't see it. You don't even have the right paper there. Oh, right here. Yeah, no, that still ain't it, dude. 228. I didn't have them tear this out earlier, but we'll get to those pages. So, there you go.
Alright,
I
that just makes sense. In the context of this
That's not it.
of this
I
problem.
thought that's what it was.
Explain the reason.
The right-hand side.
I mean,
basically.
Hello?
do it.
Yes, ma'am. Yes, ma'am.
Right hand is part.
What do you mean? Oh, well, Ms. Jemison told the juniors that they're taking it, and then the seniors are doing it that day.
I wish I was seeing it. Alright. Switch.
But the AP exam is
I got switch.
I don't even know what the call is half the time.
I got Drake.
I don't know, that's just what Ms.
You don't
Jemison.
got no OVO. I got 10 bills, bro. What?
I gotta do what's.
You don't.
Yes, I do.
10 bills.
If I
I'm talking about 10 million.
I would just ask Ms.
Look up
Jemison,
what I got.
Jemison was the
Oh,
one.
Saturday, let me go today.
Jesus, I got what?
Gotcha.
Not in a real way. God. If it's positive, it's the same. I mean, no, it's even. Right,
We do always stop
if it's negative, it'll be like different.
Okay. Sorry about that. So right hand side, what's happening? So I need y'all to remember, like, just like I annotated over there, I would annotate over here. This is my right hand side. And I need to break up the horizontal and the vertical. Here's my right hand side. Horizontally, what is happening? It is going to the right. So what is x approaching?
Positive.
Positive infinity. On that end, vertically, what's it doing? It's going up. So what is y approaching? Guys, annotate your ends. Annotate it, right? Just like you annotate in an English class when you're analyzing a passage. That's what we're doing here. This is our passage. We're annotating it to identify all this information because once you get that, it's super easy. As x goes to infinity, y goes towards infinity.
Righteous.
That's it. As x goes to infinity, y goes to infinity. That's my right-hand side. That's all it is. I do want to cover one last detail before we go to the practice, just because this I didn't get here. So I did the rest of this in first block. But I'm going to go ahead and cover this because I did not cover this in first block. So last unit, we didn't learn about absolute maximum. What did we learn about? A relative maximum and a relative minimum, right? So when did we have a relative maximum?
When it start increasing.
When it stops increasing
It start
and starts to decrease, right? So tell me when I get to a relative maximum.
right now.
Right here.
Oh, minimum, yeah, my fault.
I say that's decreasing and increasing. Okay, so tell me when I get to a relative maximum.
Right now.
Right. Notice it stops increasing. Notice how that tangent line has a positive slope, so it's increasing. And then after that, if I draw a tangent line, it starts to decrease. Okay? So that is a relative max. And someone already mentioned it. Down here is a relative minimum, right? It stops decreasing and it starts increasing. Okay, so I got a relative max or relative min here. All right, so decreasing, increasing, and then what's happening over here? It stops decreasing and it starts to increase. So we got a what right here? Relative minimum. Okay. Now, from here though, we need to recognize that this graph continues up for forever, and this side continues up for forever. That's what we just looked at, right? So are any of those the absolute highest or absolute lowest parts of the graph? Let me ask this. Is this the absolute lowest point on the entire graph?
No.
No. So that's a relative minimum, but is it an absolute minimum? No. So it's relative but not absolute. That one's the absolute lowest on the graph? Okay, so this is a relative minimum and an absolute minimum. Why do we say that? Because it's the absolute lowest. Okay, so where's my absolute highest value on the graph?
You know that one?
So infinity, there isn't one. Why do you say there isn't one?
Because it just keeps constantly going up.
I need y'all to hear this very clearly. This is one of the other most missed concepts. Students want to tell me, hey, your absolute maximum is infinity. But Damon, have you ever reached infinity? Are you ever going to reach infinity? So is infinity a value? No. Notice, we have a relative maximum, but are there y values higher than this one? Yes. So is there an absolute maximum? No. So we have a relative minimum here, we have a relative maximum here, and we have a relative min and absolute min here. There is no absolute max. Great catch on that, Lily. So we need to recognize that when we say absolute, it is the absolute highest point, or the absolute minimum is the absolute lowest point for the entire graph. If it goes up to infinity, that's not an absolute. You can't get there. All right? So just wanted to cover that. We'll come back to this tomorrow. I now need you to get out your check your understanding questions from Unit 4, and I want you to look at whatever you need to look at to go back to the test. You know what you struggled with. You know if it was converting to standard form. You know if it was finding the zeros. You know if it was sketching the graph, right? So look for the Unit 4 Frere models. Check your understanding questions. And I will be coming around to support you. You can work on vertical surfaces. You can work at your desk. You do what you got to do to be ready for that test tomorrow.